Welcome to my channel. In this lesson, we're going to be focusing on gamma function. So gamma function is given by this definition: integral from 0 to infinity e raised to the power of negative x multiplied by x raised to the power of n minus 1 dx, which is converging for n is greater than 0. So let's discuss its properties. So the first property is that gamma 1 is equals to 1. Now if we substitute n to be 1 here and solve this integration, we're going to get 1. But let's just prove it. So you have that gamma 1 is equals to integral 0 to infinity e raised to the power of negative x, then x to the power of, now n is 1 here, so we're going to write 1 minus 1, then dx. So I have that gamma 1 is equals to integral from 0 to infinity e raised to the power of negative x. Now 1 minus 1 is 0. X to the power of 0 is equals to 1. So we're just going to have the x here. So we have gamma 1 is equal to, now let's integrate this. If we integrate e to the power of negative x, we just have to rewrite it e to the power of negative x and then divide it by the derivative of the exponent. So here the exponent is negative x. If we differentiate negative x, we're going to get negative 1. So this becomes negative e raised to the power of negative x. So let's add the boundary conditions from 0 to infinity and then evaluate. So I have that gamma 1 is equals to then negative e raised to the power of negative infinity minus negative e to the power of minus 0. So this becomes negative e raised to the power of negative infinity is 0. So we have minus 0, then minus, then e raised to the power of negative 0 is 1. Then minus times minus is going to be plus, so this becomes plus 1. Now 1 minus 0 is equals to 1. So you see why gamma 1 is equals to 1. Now let's discuss other properties. So the second property is gamma n plus 1 is equals to n gamma n. The third one is gamma n plus 1 is also equals to n factorial. You're going to use this formula when n is a fraction, and then this formula when n is an integer. So let's go ahead. The first property states that gamma n multiplied by gamma 1 minus n is equals to pi divided by sine n pi. So the fifth one is that gamma half is equals to square root of pi. So let's discuss each of these properties starting from number 2, since we already established that gamma 1 is equals to 1. Now starting from this property 2, assume you are asked to evaluate gamma 3 over 2. So how do we write this 3 over 2 to be in this form, n plus 1? So we know that gamma 3 over 2 is equals to, now 3 over 2 can be written as 1 plus 1 over 2. Alright, now in this case we have 1 plus n here, so n is equals to half. So this can be simplified as half gamma half. So gamma 3 over 2 is now reduced to half gamma half. So this now becomes equals to 1 over 2. Now gamma 1 over 2, which is this, is equals to root pi. So we're going to multiply this by root pi. So this now becomes equals to root pi divided by 2. So this is what gamma 3 over 2 is. Okay, so let's evaluate gamma 5 over 2. So if we want to evaluate gamma 5 over 2, this 5 over 2 can be written as 1 plus 3 over 2. Alright, now this is 1 and then this is your n. So writing this in form of n gamma n, we are going to get 3 over 2 gamma 3 over 2. Alright, then we have 3 over 2 times, now gamma 3 over 2 is what we have found here already, which is equals to root pi over 2. So we are going to multiply this by root pi divided by 2. So 3 times root pi is equals to 3 root pi, then 2 times 2 is equals to 4, and then this is gamma 5 over 2. So let's also evaluate gamma 7 over 2. So this gamma 7 over 2 can be written as 1 plus 5 over 2. Alright, so this is 1 here, and then this is n, which is this what you have here. Now this n is equals to 5 over 2, and then writing this in form of n gamma n, you're going to have 5 over 2 gamma 5 over 2. So this is now becomes 5 over 2. Now gamma 5 over 2 is this, which we find to be 3 root pi divided by 4. So we're going to multiply this with 3 root pi divided by 4, which is equals to 15 root pi divided by 2 times 4 is equals to 8. Now this is what gamma 7 over 2 is. There's an easier way to do this. You can see that, assuming I have never found this gamma 5 over 2, this would have been a little bit tedious. Now let me show you the easiest way to do this. So we have gamma 7 over 2. Now the easiest way to do this is to subtract 1 from 7 over 2 and then start with it. 7 over 2 minus 1 is equals to 5 over 2. Then multiply by 5 over 2 minus 1 is equals to 3 over 2. Then multiply by 3 over 2 minus 1 is equals to 1 over 2. Now once you arrive at this 1 over 2, you now multiply everything with root pi. So 3 times 5 is equals to 15 times root pi divided by 2 times 2 is 4, 2 times 4 is 8. So which is the same thing as what we have here. So this is the easiest way to evaluate this type of gamma function that fell in this second property. So let's take a look at the third property. Now for this third property, we have gamma n plus 1 is equals to n factorial. So as we asked to evaluate gamma 6, so we can write 6 as 1 plus 5. So this is equals to n factorial. Here n is equals to 5, so this is equals to 5 factorial. Now we know that 5 factorial is equals to 120. Okay, so what this simply means is that this is 5 factorial. What this simply means is that if you have gamma 6, you find 5 factorial, just subtract 1 from this. Another example is gamma 4. So gamma 4 is simply going to be equals to 3 factorial. Gamma 5 is going to be equals to 4 factorial. Gamma 2 is going to be equals to 1 factorial. Just take away 1 from what you are given and then find the factorial. So here 3 factorial is equals to 3 times 2, which is equals to 6. Here 4 factorial is 4 times 3 times 2, which is equals to 24. 3 times 4 is 12, 2 times 12 is 24. 1 factorial is simply 1 times 1, which is equals to 1. So this is it for the third property. So let's look at the fourth property, which is the last one. So the fourth property is gamma n multiplied by gamma 1 minus n equals to pi divided by sine n pi. So let's assume you are given this question to evaluate. You have to evaluate gamma 1 over 3 multiplied by gamma 2 over 3. So how do you rewrite this question to be in this form, gamma n, gamma 1 minus n? Okay, so we have gamma 1 over 3, then gamma. Now this 2 over 3 can be written as 1 minus 1 over 3. Alright, 1 minus 1 over 3 is equals to 2 over 3. And then you can see now we have n here, which is 1 over 3, and 1 minus n, which is 1 minus 1 over 3. So here n is equals to 1 over 3. And so I told that this is equals to pi divided by sine n is 1 over 3 multiplied by pi. Okay, so this is equals to pi divided by, now this pi here, like this pi here in this trigonometry is going to be taken as 180, right? So 180 divided by 3 is equals to 60, and sine 60 is equals to root 3 divided by 2. So let's multiply both the numerator and the denominator by 2 to clear the fraction at the denominator. This and this will cancel. We're going to have 2 times pi divided by root 3. If you want to further simplify it, we are going to have 2 pi root 3 divided by root 3 times root 3 is equals to 3. So this is the final answer to this question. Let's solve one more question on this property. So let's evaluate gamma 3 over 4, gamma 1 over 4. So we have gamma 1 over 4 multiplied by gamma. Now this 3 over 4 can be written as 1 minus 1 over 4. Okay, so here n is simply equals to 1 over 4. So if you substitute n to be 1 over 4 here, we're going to get pi divided by sine 1 over 4 multiplied by pi. So this is going to be equals to pi divided by 180 divided by 4 is going to be equals to 45. So we're going to have sine 45 here, and then sine 45 is equals to root 2 divided by 2. So let's multiply the numerator and the denominator by 2. This and this will cancel. We'll be left with pi times 2 is equals to 2 pi divided by root 2. So if you want to do rationalization, you multiply both the numerator and the denominator by root 2. So we are going to have 2 pi times root 2 divided by root 2 times root 2 is equals to 2. So this and this will cancel to simply be equals to pi root 2. And so this is the answer to this question. So we have solved 2 examples on this fourth property. Now for this fifth one, is simply equals to root pi. So anywhere you see gamma half, you replace it with root pi. So this is it for this video. Thank you for watching. Please remember to subscribe to my YouTube channel, like this video, and share with your friends. Do have a lovely day.